The entrance of a tunnel is in the shape of a parabola, with its highest point 8 meters from the ground and its widest part 12 meters. 1. Use this information to set up an equation for the profile of the tunnel. 2. If the height of a vehicle is 4.3 meters, how far from the center can the vehicle be when driven into the tunnel? A sketch of the tunnel is as follows. It is of the parabolic shape. It would have, therefore, a shape like this. The widest part is 12 meters and the height at the highest point is 8 meters. To write an equation for the profile, we would need to have a coordinate system. As no coordinate system is given, we would have to set up our own coordinate system. We can choose the center of the coordinate system to be at a variety of points. We could choose this point, or we could choose this point, or the middle point, or the vertex of the parabola. If you choose the vertex of the parabola as the center of the coordinate system, you would get the simplest form of the equation. I am going to, however, choose the midpoint as the center of the coordinate system. The x-axis is therefore on the ground and the y-axis is perpendicular to the ground and passes through the vertex. Having set up the coordinate system, we can now write down the coordinates of certain points. For example, the vertex has the coordinates 0 for the x and 8 for the y. Also, the coordinates for the point at the far right are x equal to 6 and y equal to 0, and the coordinates for the point at the far left are -6 and 0. Since we have the coordinates of the vertex 0 and 8, we can set up the equation for the parabola using the standard form. In the standard form, the equation of a parabola is y is equal to a x minus h squared plus k, where h and k are the coordinates of the vertex. In our example, therefore, h is equal to 0 and k is equal to 8. If we plug in these values into the standard form of the equation of the parabola, we get y is equal to a times x minus 0 squared plus 8. We can simplify this to y is equal to a x squared plus 8. We note that the value of a is yet unknown. We need to find the value of a in order to have the equation for the parabola. To find the value of a, we make use of the knowledge that the point 6 and 0 or the point -6 and 0 is on the parabola. We can use either of these points and we would get the same result. 6 and 0 is on the parabola. Therefore, 6 and 0 must satisfy the equation of the parabola. In other words, if y is equal to 0 on this parabola, then x must be 6. And we would have this equation which puts one constraint on the unknown a. Since we have one equation and one unknown, in general we should be able to find the value of the unknown. We take 8 to the other side of the equation and we would have -8 is 36 times a. And if we divide both sides by 36, we will get a is equal to minus 8 over 36, which we can simplify to minus 2 over 9. I keep this result as a fraction because if I convert this into decimals, I would have to round the result, which is not something we would want to do. We can keep the value of a exact. Let's put this value of a back into the equation. We would have y is equal to minus 2 over 9 x squared plus 8 as the equation for the profile of the entrance of the tunnel. Note that if we had used a different coordinate system, we would have found a different equation. Let's now look at part 2 of this question. There is a vehicle with height 4.3 meters. We could think of it as a truck which is carrying a load. And we're wondering how far from the center this vehicle could be before it collides with the interior of the tunnel. Let's sketch the possibilities. One possibility for the vehicle is to be as far to the left as possible. That would be here, for example. The other possibility for the vehicle is to be as far to the right as possible, which would be somewhere here. Before it would collide with the interior of the tunnel. Now, if we look at any of these two possibilities, we see that the y coordinates of the points where the collision would occur are given, because the height of the vehicle is given. It is 4.3 meters. But the x of this point is what we are looking for. I call this D. Now, this point, the point of collision, is on the parabola. Therefore, its coordinates, which are D and 4.3, satisfy the equation of the parabola. Let's plug in these coordinates into the equation and see what we find. If we plug in the coordinates D and 4.3 into the equation, we find 4.3 is equal to minus 2 over 9 d squared plus 8. We can solve this equation for d. Move 8 to the other side of the equation to get 4.3 minus 8 is equal to minus 2 over 9 d squared. 4.3 minus 8 is minus 3.7, which is equal to minus 2 over 9 d squared. If we cross multiply this equation to isolate d squared, we find that d squared is 9 times 3.7 divided by 2, which is 16.65. Therefore, d is equal to plus or minus root 16.65, which is approximately equal to plus or minus 4.08. Let's now interpret this result. D is the x-coordinate of these points. I call them A and B. The negative value of D corresponds to point A. Therefore, this is 4.08 meters. And the positive value corresponds to point B. 4.08 meters. As we can see, both the positive and negative roots can be interpreted in a meaningful way in this example.